this recording. I am sad that it's our last class. I know. But I'm also pretty excited for the holidays, so you don't have to feel bad if you're excited for it too. Right? All right. We did question 19. A contract requires, so that's where we ended off. So we're going to pick up at question 20 then. Oh. So, final exam review, part 2. So you got your test 3 back. I was a little bit disappointed with the mortgage question. I feel like if you got it, you got it, everything's good. But then it's supposed to be the easiest question. So just make sure that you have it under control for the final, and we'll do one today. Hopefully we won't run out of time, but usually works out. So make sure the mortgage question is supposed to be like the easiest marks on the final. So make sure that it is. Well, they all should be pretty easy at this point. No, not easy, but familiar. All right. So we're working through the practice final. What's the value 1.5 years from now of the following payment stream using a 4.1% monthly compounded rate of interest? So we've got a payment 1 year from today of $15,000 and a payment 6 years from today of $2,000. All calculations must be done without the help of the time value of money, TVM functions of your financial calculator. So even though you should use it to check your answers, right? Go ahead and use it to check your answers. But you have to show your work that you're doing by hand. Yeah? So the TVM functions are just the white buttons on your calculator. All right. So we see that we just have 2 payments that we're talking about, right? A payment a year from today and a payment in 6 years from today. And so that's not regular payments, right? And so we're just in compound interest again, right? And so where's my formulas here? So we're still in this section here. These are our formulas that we have available to us. So it's going to be really helpful if you can identify what type of problem that you have, right? Because then you can really zone in on your formula sheet, especially for these earlier questions. And like I said, they will be in this order. I don't change things up. I don't go crazy like that. So you could just memorize it, I guess, or recognize them. There's an idea. All right. So from here, I'm going to start making my timeline, right? I've got, well, referencing today, right? I've got a year from today and a payment 6 years from today. And then obviously I'm going to put today on there. So I'm only seeing 3 ticks. And so here we go. And what you'll find is the ones that you have to do by hand are not going to be that bad, right? They're going to be pretty reasonable, nothing crazy. Why do I have, oh, good thing I've got my Martha Stewart solutions here. What is the value 1.5 years from today? I guess we would have figured out to look for it, but we need to have that on our timeline as well. So we have 4 ticks. It was too good to be true. So it's all in reference of today. So just as a reminder, right, we put the dates on top of the ticks and the dollar amounts below the ticks. And so we've got today, and then in order of appearance, we've got 1 year, 1.5 years, and 6 years. So 1 year, 1.5 years, and 6 years. Because we want to know what the value of this payment stream is at 1.5 years, right? That's what makes this the focal date. And maybe I'll write that on here too, up top. That's the focal date, right? So that's where we want to draw our payments to so that we can figure out what they're worth. Cool. Now we've got payment amounts. So 15,000 1 year from today and 2,000 6 years from today. 15,000 and 2,000. The 15,000 is getting pulled forwards for half a year, right? So that's going to be a future value. The 2,000 is getting pulled back, right? So that's going to be a present value. And only to denote the order that I'm doing these calculations, I'm going to find future value 1 and present value 2. Not really necessary because they're different things. But it could very well be that we've got 2 future values, and so we want to differentiate between those 2. Right. And so I did mark you guys pretty hard on your timelines because I want them to be really good on the final, right? And so as long as I see better timelines on the final, then we can kind of overlook the bad timelines that we had here. They were pretty bad. So can work on those. Here we go. So we want to know what's the total value. That's the future value plus the present value. Total value. For compound interest, right? Our N is time times the frequency. That's our compounding frequency because we don't have a payment frequency. As soon as we have a payment frequency, then our N is the number of payments, right? And so we use T times F, where F is the payment frequency. So in this case, right, we've got N is T times F. Time in this case from 1 year to 1.5 years is just half a year, right? You want to be careful. So 0.5. And what was our compounding frequency? Monthly. So 12. So I get 6. And then from 1.5 years to 6 years, and is time times the frequency again, we've got 4.5 years times 12, which is 54. For these problems, right, we just kind of calculate I on the side somewhere, just so we have it. I'm going to highlight that R is 0.041. And I'll use the new notation, sort of new. Compoundings per year was 12, which is our F, which later on when we have payments, right, it's technically our F1. So then I is R over F, which is 0.041 divided by 12. 0.041 divided by 12, 0.003416667. I'm going to store this in 1. If you're going to use and tell me that you're going to recall something, you have to tell me what you stored in that number, right? Otherwise, I can't figure out where it came from or even what you're using. So, all right. here's our complete timeline for this problem. Besides saying where the focal date is, nothing else is extra, or kind of everything has to be on there, right? And it's just helpful to highlight where the focal date is. So let's get to our calculations. Future value is the present value times 1 plus I to the power of n. The present value for this future value is 15,000 times 1 plus, and here's where I'm going to say recall 1 only because I said I've stored it in 1, to the power of n, which is 6. So plus 1 to the power of 6 times 15,000. My future value, 15,310.13856, which we're talking money, so we'll round to 2 decimal places, 15,310.14. Same idea, so let's solve for the present value too. We've got the formula right on our formula sheet, right? So we're using the future value and the present value formulas. It's the future value over 1 plus I to the power of n. The future value for this guy is 2,000, and making a note that our n is 54. 2,000 over 1 plus, and I'm just going to do recall 1 to the power of 54. Recall 1 plus 1 to the power of 54. And then 2,000 divided by that puts me at 1,663.562941. We're going to round that to 2 decimal places, of course, 1663.56. So the total value, 1.5 years from today, is future value 1 plus present value 2, which is 15,310.14 plus 166356, which is 16,973.70. So we had to do it by hand. You're allowed to check your work, right, using your calculator. That's fine. But you have to show that you know how to do it by hand. Okay? But like I said, very kind of reasonable problems for the by hand ones. Any questions about that one? All right. Then let's go on to the next one. Question 21. As promised, right, there are 2 questions that you may not do only by using your calculator. I encourage you to check your work with your calculator, right? But here's the next one that you have to do by hand, and it's going to be an annuity question, right? So you've got these regular payments. So now we're on the flip side of your formula sheet, right? And so, but again, it's going to be very kind of manageable in terms of the problem, right? And you had one on test 3. I think it was actually pretty good. So, yeah. All right. Herbert decides to invest $1,000 at the beginning of each month to his RRSP. If money earns a rate of return of 4.5% compounded annually, what amount should Herbert expect to have in his RRSP after 10 years? And then here I'll just highlight do all calculations without using the TBM functions of your financial calculator. Okay. So for annuities, right, we said, okay, well, I want to see 3 ticks in the front and 2 ticks in the back. I don't need to see the rest, right? We just connect them with ... So let's make our timeline here. And so let's say we start today, and then 1, 2, and then the last 2 there. And then we separate them with ... to indicate that things just keep going this way until the end that I've shown. All right. So he's investing $1,000 at the beginning of each month, right? So if it's at the beginning, remember how to show that instead of putting the payment here, the first payment here, 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 right? We shift all these payments over one so that the first payment is today and the last payment is the second to last tick, right? Because if you imagine this being the payment period, right, you're going from the end of the payment period to the beginning of the payment period, and that's how you're going to show me that you have picked up on it being at the beginning. So we were going to put these $1,000 at the beginning of each month. Okay. So the first 2 months are fine, 1 month, 2 months, but then we need to figure out how many months we're talking about, and we want 10 years, so I'll put 10 years kind of up above. But in months, right, that's 120 months. So then the second to last tick is 119 months. So now he's saving money, right? So these payments are all going to funnel into a future value at the 10-year mark, right? And because these payments are at the beginning, right, it's a future value due. So I do these curly brackets, right? But that's only because I think they're really fun to draw. You could definitely just do a square funnel if you wanted to, right? Like that. But like I said, I really like drawing curly brackets. So this is going to become a future value due, right? Because these payments were at the beginning. Now, we've already calculated our n, so showing it on the arrow is kind of a formality. N is time times the frequency. Time is, 10 years, 10 years times monthly payments, right? And so 120, which we already had to find to do our ticks, right? So that's why I say it's more of a formality. So now we know our rate is 0.045 and our compoundings per year is annually. This is going to be our F1, right? That's our initial compounding frequency, and our payments per year is 12, which is our F2, right? That's what we're going to need to change our compounding frequency to be, right? To match the payment frequency. And so I'll just make a note here. Since F1 does not equal F2, and I was really impressed with you guys for having this under control. Since F1 does not equal F2, we need to calculate I2. So, which means we have to find I1. I1 is R over F1, 0.045 over 1, which we can all kind of handle, 0.045. So now I2 is going to be 1 plus I1 to the power of F1 over F2, and then minus 1. This is 1 plus 0.045 to the power of F1, which is 1, divided by F2, which is 12, and then we're going to subtract 1. So 0.045 plus 1 to the power of 1 over 12. Oops. I screwed up. And then minus 1. Correct me if I had a slip here, but I get 0.003674809. Which I'll store in 1. If you've got a system, right, where you store I1 in 1 and I2 in 2, then that's fine, but I always fill 1 first. I had a student who said that he always just stored his interest rate in 0. 0, I didn't even think it was an option. No, I don't consider it an option. I go for 1. All right, so now, what's nice is you don't have to take care of I2 if you're doing it on your calculator, right? But that's why I make you do it by hand for this one, right? Just 1, and it's not that bad. So we're gonna find the future value due. The future value due is the PMT times, now where's our, oh, you know what I forgot to do? Bring in our formula sheet. I'll put it here. Right, if we have payments at the beginning, then we have an annuity due, and so these are the formulas. The formulas on the right hand side, those are the ones that we're going to take from, right? And so our future value due is PMT times 1 plus I to the power of n minus 1 divided by I, and then we tack on the 1 plus I. This is going to get pretty big and nasty, so I'm going to actually bump it down to the next page here where I've got some room. Not too bad if you just say recall 1 for all your eyes. Right, but we've got our payment amount, which for us is 1,000, and then times 1 plus recall 1 to the power of n, which we said was 120, and then minus 1, all that over recall 1, and then times 1 plus recall 1. So moving from our big brackets to search for little brackets in there, we've got little brackets. And so we've got 1 plus recall 1 to the power of 120 minus 1. And then we kind of bloom out. Just so you can have a little check-in point here, and you don't have to, you can go straight to the answer. This would be 1,000 times 150.475671, and then times 1 plus recall 1. I don't want to write it out. Times 1 plus recall 1 and then times 1,000, I get 151,028.6435. So in money, that's $151,028.64. Looks like this is never fun when my iPad's running out of juice. My pen jumps around. Yeah, do you find that too? Yeah, I find that when it's plugged in, the pen like does weird stuff. You'll see.
Are these the ones that you could use either eye for as long as you use the proper?
No, this one you would have to use I2. It's for if you have a deferred annuity where you've got compound interest, then you can use whichever one is to find your end, but as long as they're matchy-matchy. Nice. Any questions about this one? Pretty good. It's by hand, but not too bad. All right. Cool. So this is the one that I managed to print it off before changing it, even though I had a big pink sticker on my old one saying, change it. I'm like, nope, print. I don't know. I've changed it now, finally. But I think on your handouts, it might make sure it doesn't say, I think 20 years is what it said, which doesn't really make sense because it's one of those kind of big nasty ones, right? You're making payments, it's going to sit there, and then you get payments, right? We did one in class, we did one on test 3, there's going to be one on the final. You're going to be pros. But he's making payments over 23 years, and then what biweekly investments should you make over the next 20 years? It didn't make sense. So, but might be a good hint as to what the actual final exam question might be. 20 years changes everything. Because I just took the final exam question and I changed some stuff. That's it. But that's what I did for all of these. Oy. Okay. Just be cool, right? Just passes. Pink screen and everything. All right. So you've decided to invest in your RSP over the next 23 years. You intend to make bi-weekly contributions over this time period, with the first one beginning today, right? So they're at the beginning of the payment period. When you retire in 30 years, you would like to receive $1,500 a month and contributions for the next 25 years. So we've got 23 years, 7 years where it just sits, and then 25 years where you're getting payments. Right? So if your investments earn a rate of 8.25% compounded quarterly, what biweekly investments should you make over the next 23 years? So this one, I really, really, really think that you should just use your calculator. It's going to be a lot easier. I didn't see anyone try to do it by hand on the test, so that's good. Be very time consuming. All right, so we're gonna make our timeline, and it's gonna feel kind of cramped here, but oh, I don't need a ton of room for, oh man. That was my bad, I had the eraser on. I don't need a ton of room for the time where it just sits there, right? Because it's hard to show all those little payments, right? Going in, coming out. So here we go. All right. So you're going to make bi-weekly contributions for 23 years. So over this here, I'm just going to make a note to myself that that's the 23-year mark. Here's the 30-year mark, right? Because that's when you officially retire. Hopefully this question feels kind of familiar from test 3 and also in class. But so when you retire in 30 years, and then you want to get payments for 25 years, which puts you at 55 years, right? Where this distance is 25 years, this distance is 7 years, and of course this distance is 23 years. Getting messy. So if we start today, and we're making bi-weekly contributions for 23 years, then we need to know how many bi-weeklies we have in 23 years. So we've got 23 times 26 is 598 bi-weekly payments. So we end at 598, and I'll just call them BW. Okay, which means that my first 2 ticks are 1 BW, 2 BW, and then the second to last tick is 597 BW.
Not in the first one, isn't it D?
Yeah, but we'll show that with the payments. So here, the ticks will all be the same, but where we put the payments, or which ticks we put the payment underneath, that's what's going to show if it's due or not. But yeah, it is at the beginning today. So we don't know what these payment amounts are, but I'm going to start today and I'm going to make some unknown payment amounts, PMT, 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 and the last one is going to be under the 597 tick. Now, depending on how you want to map this out, right, you probably have a preferred way of mapping this out, and that's great. We could funnel these. They're going to become some future value, and then that's going to become the present value of where it just sits there. But what I'm going to do is I'm going to jump to, let's call this a 3-phase problem, right? Phase 1, phase 2, phase 3, right? Or phase 1, 2, 3, because that's how we're going to have to do our calculations, right? But what I'm going to do is I'm going to put my payments on this last chunk here, just so I have them all to visualize. And so when you retire in 30 years, you would like to receive 1,500 month-end contributions for 25 years. So here I'm going to have 1 month, which I'll just use 1M because we're a little bit tight. 2M, and for 25 years, there's 300 months, right? Careful that you don't use the 55 years, right? Because this time frame is only 25 years. And then 299 months. I'll call that 0 months, just to have something to call it. So I want month end payments of 1,500, 1,500, 1,500, and 1,500. Because we've seen this problem before, right? I'm going to funnel those 1,500 into a present value because that's the first thing that I'm going to have to calculate. Right, so I'm going to do the arrows in the order that I have to do these calculations. Right, and so these all get pulled back to a present value. because these payments are at the end, it's just a regular present value. And to indicate that this is the first thing I have to find, I'll put a subscript 1. This is going to have to be the same as the future value after all those payments have been compounding for 7 years, right? Collecting payments for 23 years, and then they sit there and they compound for 7 years. And so that's going to be the same as, let's call it future value 2, even though there's no calculation involved, really. Right? But it kind of switches persona from being a present value to a future value, depending on what you're talking about. So then this future value can get traced back to the present value. And I'm going to call this present value 3. That present value 3 is going to have to be the same as the sum of all these payments, right? Not really. Well, it is a sum, right? Plus interest, which is going to be a future value. And because these payments are at the beginning, it's a future value due, which has to equal the present value 3. And I'll call this future value due 4, because that's the last step. And then we'll be able to solve for our payment amounts, right? So lots of steps, lots of fun. So here we go. All right. I wasn't too picky about having the N on the arrows for these annuities because we have to calculate them to put the ticks on the timeline anyways. So it was more for compound interest and simple interest, we put time, right? So I'm just going to put them here. I'm not going to show the calculations mostly because I don't have room. Here, N is 598. For this little section, my N is going to be just the number of compoundings. 8.25% compounded quarterly. So N is time times the frequency. In this case, it's 7 times 4, which I hope is 28, but I don't know. Yeah, it is. Okay. And then what we also want to keep track of is, okay, hey, how nice is that? The interest rate is the same for all of these. 8.25% compounded quarterly. It doesn't change. Whereas I feel like on test 3, I had it changing. Right, it was changing for some of them. And so that is great. Very easy. Not very easy, I shouldn't say that. 0.0825. And the compoundings per year is quarterly, so 4. If we were doing this by hand, right, then we would have to find I2, but we're not. So I'm just going to get right into showing my calculator work. And so one thing that I do want to mention again is I want to see your calculator inputs in the same order. And that's just me trying to speed up my marking. It's very difficult when everything's in a different order, right? And so I want to see them in this order. I'm going to split this page into 3 sections, giving the middle section a little bit more room because otherwise it's hard. And then depending on what we want to call this, if we call this phase 1, even though chronologically it's phase 3, phase 2 and phase 3. I'm going to move these guys up here. So the way I want your calculator inputs ideally is, oops, your N on top and then the interest per year. And I'm just running through them as they appear on your calculator. The present value, the PMT, the future value. And then we flip through to the payments per year and the compoundings per year. And then the last thing we check is if we're at the beginning or the end. And then because I know you have to write it out too, I'll do the same, but I'm just going to write these out 2 more times.
Can you show us how to do phase 2 of the calculator? Because I was having problems with it before the test. She did it instead.
In fact, we will.
Huh?
We will. Got it. All right. So we'll start over on the right, which is probably not what you want to do, but that's how we have to work through these problems, right? And so we start in phase 1, as I've called it, and we know our N here is 300. Our interest per year is 8.25 for all of these. So I'm going to go ahead and fill in 8.25, 8.25, and 8.25. We also know that the compoundings per year are 4 for all of these. So that's just really nice that things aren't changing on us. We're solving for the present value in phase 1, so I'm going to show that by a little asterisk. My payment amount is $1,500. Because I'm getting these payments, that's going to be positive, right? And then the future value is going to be 0, right? Once I've used up all my funds, then I don't have any more money. Just grab your test. And we have monthly payments, and so we have 12 payments per year. And we said that these are at the end. Oops. So we have to be in the end mode. All right. So entering these values, 300 and 8.25 interest per year, 1,500 payment amount, 0 future value, 12 enter payments per year, 4 enter compoundings per year. And then just make sure that you're in the end mode, and then we can compute the present value, and I get negative 191,154.2953. Which I'll highlight here. I can only have money, right? So money can only have 2 decimal places. And so this present value, right, from our map becomes the future value in phase 2, right? So I'm just going to jot that down, but changing it to just 2 decimal places. So 191,154 and 30 cents. Now you'll want to put some time into thinking about whether the future value is positive or negative. There are instances where it doesn't really matter, because we're fake taking money and fake putting it back in, right? And so at each exchange, right, these payments, the initial payments that we're making, right, these are going to be negative, right, because they're definitely leaving us, right? And so this is going to be positive because the idea is that, okay, fine, I've saved it, I take it out, and then immediately I go and buy something, right? So this would be positive technically. And then at the end, no, positive, pay it back, negative, get it out, positive, pay it back immediately to get payments, right? So negative, and then positive payments. So in this case, it doesn't really matter. A lot of those short answers, I saw people getting a loan and trying to pay it off by getting a loan every month, for example, right? And so then it's really important that you keep those negatives on your payments, right? Because you're trying to pay it off, okay? So here, this future value is going to be, what did we say? I make payments, I get them, I put them back in, positive. Okay. And then I can fill in the rest of the values. Here we found that n is 28, just 28 compoundings. The present value is what we're trying to solve for, so I'll put a little asterisk there. What we do when we have no payments, right? If it's just a compound interest problem, we put 0 for our payment amount. And then you force the payments per year to be the same as the compoundings per year. And it shouldn't matter, but just for simplicity's sake, let's put it at the end. But because there are no payments, it shouldn't matter when the payments are, because if they're at the beginning or at the end, shouldn't take it into account. So try. All right, so let's do these calculations then. 28 for n, 8.25 for the interest per year, 0 for the payment, 191,154.30, right? Rounded to 2 decimal places because it's just that money exchanging hands. If you kept all your decimals, it'd be fine, but 1915, oh, I missed the 4. 4.30. That would make a big difference. Is the future value, and then I've got 4 payments per year and 4 compoundings per year. And I'm still in n mode, so now I can compute my present value. I get negative 107,927.0766. Is that what you got, Mark?
No, but
Yeah. I want to make sure that we get the same. So then here, oh, that was a bad color, I guess.
That's it.
927. Yeah, it says sloppy 2 though, on my part. So this present value becomes the future value of your payments that you're trying to solve for. And so we've got 107,927.08. Our N for phase 3 is 598. The present value, we're going to start with nothing, right? So that's going to be 0. And our payment, that's what we're solving for, so I'll put a little asterisk there. And then we've got bi-weekly payments, so we've got 26. Compoundings per year is still 4. And then we have to make a note that we're in the begin mode So that we're gonna have to change. In fact, I would probably just change it right now. So remember how to do that. Second payment, second enter to change between beginning and end. So make sure you're in begin mode, and then we can plug these in. 598 for N, 8.25 for the interest per year, 0 for the present value, 107, 927.08 for the future value, 26 payments per year, enter, 4 compoundings per year, enter, and then compute PMT, and I get negative 61.07248259. Yeah, nice. And did you figure out phase 2 there?
Yeah. It was because I wasn't sure about compounding and payments. It would stay the same as the other one because I wasn't sure if it would stay in the same account or not.
No, just 0 for the payments, and then the payments per year force it to be the same as the compoundings. Cool. So I would need to make bi-weekly investments of $61.07 for the next 23 years. Oh yeah. Any questions about that one? I'd say it's definitely the hardest question on the final, right? Mostly to wrap your head around. But then if you've seen it like this before and you know how to map it out, right? I'm not going to change anything. You're going to have to solve for the payment amount. It's just the situations in between that are going to change, right? But it'll be 3 phases like this. Okay. So let me steal the next question, which you also had on test 3. Actually make it a point to make sure that you've seen all of these problems one way or another in a test situation, right? So that they're not jumping out at you. Are you done there, Alyssa? Yeah. Okay. So Ernie currently has $40,000 in his RRSP. He will let it collect interest at a rate of 3% compounded monthly. It's an annuity that pays $1,500 at the beginning of each month for 20 years. This is different from test 3, right? Because there I had a perpetuity because I wanted to get a perpetuity in, right? But now it's just going to be an annuity for 20 years, but the idea stays the same. While money earns 6% compounded weekly, how long will Ernie need to wait until he can retire? Okay, here we go. So our timeline has an end now, right? Not a perpetuity anymore. And we'll start today. And there's only 2 phases to this problem, right, as opposed to the 3-phase problem. And so at some unknown point, he's going to retire. And so we don't really know when that is, right? But that's okay. All we know is that for 20 years after that, he wants to have payments of $1,500 at the beginning of each month for 20 years, right? And so here we've got 20 years from retirement. And he's going to have monthly payments. And so for 20 years times 12, there's 240 months. And so if we call this retirement point 0 months, and then the next tick 1 month, following tick 2 months, and then second to last tick 239 months, that'll be good. He wants 1,500 at the beginning of each month. So I'm going to start this 1,500 at the 0 month mark and go until the 239 month mark. Same idea as the perpetuity, right? But now we've just got this 20 years of an annuity. And so what's nice is we can use our calculator for an annuity, whereas a perpetuity, we had to do it by hand. It's easy, but we had to do it by hand. All right, and so these payments all funnel back to some present value and due because all these payments are at the beginning of each month. So what we want to know is we want to know he has 40,000, which has to grow to a future value, which is going to have to be equal to that present value due, right? That's the value that can sustain these payments that he wants. Here's a holdup. We do have different interest rates for this section, right? And so he will let it collect interest at a rate of 3% compounded monthly. That's for the savings part, right? So below here somewhere, I'm going to say R is 3% and the compoundings per year are 12. Whereas in the second section, he will retire when he has enough, blah, 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 while money earns 6% compounded weekly. So then for this section, R is 6%, and our compoundings per year are 52. Okay. Here, for the second section, right, we've got payments per year, right? But what I'm going to do is I'm just going to do both of these on my calculator because we're allowed to. It's easier, right? And so instead of kind of mucking around by hand, which you're welcome to do, but I don't know. Once you have the calculator figured out, it's pretty good. I know you guys don't like the calculator in the beginning. I tell you, you're gonna like it. Saves you a lot of time. So let's call this phase 1, right? Because that's where I have to find the present value. So find what amount I need 40,000 to grow to. And then I'll call this phase 2, but same idea, right? I'll write out my calculator inputs and then just put them in my calculator. So I've got N interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. Same thing over here, and interest per year. Present value, PMT, future value, payments per year, compoundings per year, and beginning or end. So because I don't want to forget that I have a different interest rate for each of these sections, right, I'm going to start by just filling in this interest rate in phase 1, and the compoundings per year is 52. And then for phase 2, I've got 3 and 12 compoundings per year. So I've already found my N. In fact, I got sloppy because I didn't put my N on my arrow, right? I just put it up top. Here I'll put N is 240. It'll be more important for that compound interest section, right? It gets confusing because we always have compound interest now, right? As soon as we're out of simple interest, it'll always be compound interest. But when we have these regular payments, I'll call it an annuity instead, right? And so we've got N is 240. Our interest is 6%. Our present value is the one we're solving for, so I'll put a little asterisk there. And then our payment amount is 1,500. Now here it is important that we check, okay, are we getting these monies? Yes, we are, right? So it's going to be positive. Once that's all gone, we have a 0 future value. And the number of payments per year, we've got monthly payments, so it's 12. And we do need to make sure that we're in begin mode, or else our answers will be just slightly off, right? Off by 1 month of interest. So very tiny, but still off. Okay, so then solving for the present value, 240 for N, 6 for the interest per year, 1,500 for the payment amount, 0 for the future value, 12 payments per year, 52 compoundings per year, and I'm still in begin mode, so I'm okay, and then I can compute my present value. I get 210,224.4794. Now, whether you want to do the calculation by hand, right, or if you want to use your calculator for the compound interest section, it doesn't matter. I'm just going to use my calculator because I think it's easier, but you should get the exact same answer, right? So it doesn't matter. But for our compound interest section, we have to figure out what our N is, right? And so now N is the number of compoundings. And so N is time times the frequency, which we don't know because we're trying to figure out time, right? Which means that N is the one that we're solving for. Right? But it's just a good reminder that here, once we have N, we need to find time, right? How long until he can retire? Which means we have to first find N and then divide it by F to find T. Right? So our present value is 40,000. And the idea here is going to be that you invest this 40,000, and so it leaves your hands negative 40,000. Our payment, there are no payments, so we put 0. And then our future value has to be positive. Again, here it doesn't actually matter. We said for compound interest, as long as one is negative and the other is positive, for the present value and the future value, it doesn't matter. So then we've got our future value has to be the 210,224.48, rounding to 2 decimal places, right? Trying to show the links here, but I'm doing it different ways every time, I guess. I don't know. So then our payments per year, we just force it to be 12 to be the same as the compoundings per year. Because one of them has to be negative. And the way I'm saying it is that, okay, so you've got 40,000. Now, today you're going to invest it in an RRSP, right? Even though it says it's already in there, the idea is, okay, it leaves our hands and then it sits there and then we take it out. Does that make sense? And we're going to force this to be at the end, even though I'm pretty sure it doesn't matter. So I'm going to change it to the end mode. Takes a little longer, I guess. There we go. We're solving for n. We've got 3 for our interest per year, 40,000 negative for our present value, 0 for the payment amount, 210,224.48 for our future value. And what you'll notice is as soon as you change your payments per year to 12, your compoundings per year are also 12. Right, so it'll force it to be the same, and then what we've been doing is changing the compoundings per year if we have to. Right? So then now we can compute our n, and we get n is 664.54788862. So that's our n. I get 664.547. Let me check here. Oh, yeah. You're way ahead of me. So we would need, or I guess Ernie would need to wait, it doesn't matter. We would need n equal to 665, right? N equal to 665. And then I'll just highlight that these are compoundings. Because if we go to 664, for example, right, even though with proper rounding we would go to 65, we wouldn't quite have the $210,224.48 that we need, right? So that's why we have to take it a little bit further. We'll have a little bit more than what we need, right? But it's okay, that's better. So remember that n is time times the frequency, where the frequency now is the compounding frequency, right? And so we've got 665 is time times the compounding frequency of 12. So T is 665 divided by 12, 55.4166, repeating. Or T is 55.42-ish years. Usually I say how you need to round your values. Otherwise, I'm pretty lenient. Pretty lenient. Any questions about that one? Well, that's the answer. 55.42 years. So almost 55 and a half years. All right. No worries. I think you've spent enough time in this room. All right. Mortgages. Last one. You can do it. And I did it. I sent mine. You're all good. You are all good. See you later, Mac. All right. Same as test 3, right? Just a mortgage question. It's just a mortgage question, but quite a few to practice on, right? And so I'll just steal this here. All right, and actually I'm gonna split it up. We'll do A first and then B. I'll show them separately. All right. So here we go. You're going to purchase a home. Surprise, surprise. You're going to make a 10% down payment and repay the remainder of the mortgage at a rate of 3.9% compounded quarterly. So the first part is always going to be calculate your end of month payment, or whatever I say, beginning of month or whatever, if your amortization period is 25 years. I'm not even going to draw a timeline because that's not what the question is all about. It's more going to be about finding our PMT. See you, Nate. Been a slice. All right. So from all this, right, we can just put it in our calculator and figure out what the payment amount is, right? And so what we've got is, and I'm going to arrange them like this now to save myself a little bit of space, and interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. Your N, is your time times your frequency. I just want to put this here because just in case. Time is 25, and the payment frequency, right, because you want to have your N is the number of payments. If you've got regular payments, your payment frequency is 12. So 25 times 12 is 300. Right. Our interest per year is nothing special, 3.9, and then compounded quarterly, and so we've got compoundings per year is 4. We also decided that our payments per year were going to be 12, and they're at the end of the month, and so we have to be in the end mode for all of these calculations. We're solving for our PMT, so I'm going to put a little star there. And then the future value, once we're all paid up, has to be 0. And so what I have to find, though, is my present value, which is the value of the mortgage, right? It's not the 500,000. It's the 500,000 less the 10% down payment. So it's 500,000 minus 500,000 times 0.1, or however you want to do it. It doesn't matter, right? 500,000 times 0.9 is going to give you the same answer. but 500,000 times 0.1, 10% of 500,000 is 50,000, right? And so we get 500,000 just showing more work than we need to at all, minus 50,000. So our present value is 450,000. In terms of where is the money going and coming from, right? The idea is that we get this money, the 450,000, and then we pay it off with negative payments, right? So this is, the present value has to be positive. Oh, I know I've been trying to avoid my low battery this whole time. And so now I'm ready to solve for my payment amount. So 303.9 interest per year, 450,000 present value, 0 future value, 12 payments per year, 4 compoundings per year, and I'm at the end and I'm in end mode, so that's good. So now I can compute my PMT, and my PMT is going to be negative, and because we're talking in the calculator inputs, it's going to be important that it's negative, right? And so negative 2,347, and I'm going to round right away to 38 cents. So therefore, our payments must be 2,347.38. Oops. Any questions about that one? All right. So our next thing is going to be to make our partial amortization schedule, right? Nothing crazy, as long as you've got the kind of the steps figured out. First thing we need to do, though, the only real calculation that we're doing for this question is finding I2, right? Because what we see here is our compoundings per year is not the same as our payments per year. And so we need to find I2 to calculate the interest amounts. To calculate the interest amounts. And so we've got our compoundings per year is 4, which is our F1, and our payments per year is 12, which is our F2. I1 is 0.039 divided by 4. So I1 is 0.00975. Whether you want to store that or just use it in I2, doesn't matter. So I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.00975 to the power of 4 over, 12. Almost wrote 52, not sure why. Which I find is plus 1 to the power of 4 divided by 12 minus 1. I get 0.003239494, which I'm definitely going to store in 1. All right. So now that we have I2, right, we have everything that we need to be able to fill in the table. And the table's on the back page. Oops. Make this as big as I can so we can fill it in. All right, we wanted the first and the second payments, the 250th and the 251st payment, and the final two payments. So we know, here are some rules, right? Payment number, the first one is always 0, right? And I want to see the 1, 2 payment. There's going to be just enough room for one row of dots, dot, 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 until you get to your next row. 250th, which means I need the future value at the 249th payment. So 249, 250, and 251. Dot, dot, dot. And then we know our N is 300, so the final two payments will start at the bottom, 300, 299, and then to get the final, the 299, I need the 298. Our payment amount is the same. That's the amount that you found, right? 2347.38. It's positive because we're not talking in terms of the calculator. Oh, what did I do wrong here? There's nothing in the 0 row. I could feel you guys reacting. Hey, I thought you said. You're right. 2347.38. And that's going to be the same for all of these, except for the very last payment. Now, whether you want to do ditto marks or whatever, it doesn't matter. Right. Making sure that you don't put that amount for the last payment because it will not be the same. I can guarantee it. All right. So our balance, our 0 balance is 450,000. That's our present value, right? So 450,000 is our original balance. That's the balance that we have to pay interest on, right? And so we take that balance and we multiply it by I2. So times 450,000. Rounding properly to 2 decimal places right away, the amount of interest that we have to pay is 1,457.77, which means the principal is the payment minus the amount of interest that we've paid. And so we get 2347.38, which I'm going to store in 0 because I'm going to use it quite a bit. There, look at me go, storing in 0. I'm wild. Minus 1457.77, I get 889.61 for the principal, and that's what I can deduct from the balance owing. So I have 450,000 minus the 889.61, and I get 449,110.39. You want to make sure, yeah. Oh, it's this amount minus this is this. You want to make sure that you're always decreasing as you move through here. I saw quite a few mortgages where it was decreasing here and then all of a sudden it was going up, probably because those payments weren't negative, right? And so you want to make sure that you can use that to kind of check your work, right? Does this make sense, what I'm saying here? And then instead of doing the calculations, I'm just going to give you the values for the next row in the interest of time. 1454, and you can check your work. 892.49. And the new balance I get is 448,217.90. And then we've got ... until we have to find the future value at the 249th payment. And that's how we find our balance at the 249th payment. And so we did this before, but it doesn't hurt to do it again. Oh, I guess I just crossed out part C because we're going to do it later. I just need this room to show my work here. Although you definitely don't have to. I'm only looking at the table. And so this is going to be the future value at n equal to 249. Right? So if we're thinking about n, our interest per year, our present value, our PMT, our future value, our payments per year, our compoundings per year, and beginning or end, the only ones that have changed now, right, is our N 249. Our interest per year stayed the same, 3.9. Present value is still 450,000. That's what I'm still paying off. Yeah. I don't know why I'm hesitating. 450,000. I have to make my payment negative, right? Otherwise, I'm just taking out more loans. 2347.38. The future value is what I'm trying to solve for. And my payments per year and compoundings per year all stay the same, 12.4 and end. So I can go ahead and find my future value. So 249 for N. The only ones that have changed, right, is the N, adding the payment. The rest have stayed the same, so I don't actually need to go back and change them. You can if you want, but I'm just going to do the payment 2347.38 negative. Oh, that wasn't a number. 2347.38 negative for my payment amount, and then I can compute my future value. The future value, I don't have enough room to put it on here, so oops, put it down here. Did something weird. I get 110,184.0044. It's doing it again. It's complaining because it's plugged in. There. So rounding to 2 decimal places, that's 0 pennies, and it's negative, right? Because the idea is, okay, if you stop after 249 payments, you would owe $120 or $110,000 still, give or take. Actually, more like give. 110,104.00. So we don't know what these values are leading up to it, but that's okay. We need it to be able to find the next row. And then, so it's important that you make sure that you get the same value for the 249. And then again, in the interest of time, I'm just going to give you the rest of the numbers. So then you multiply that by I2 to get 356.94. Subtract that interest amount from the payment amount to get the principal 1990.44. That I can chip away from the balance. And so now I owe 108,193.56. And then the next line, 350.50, 1996.88, and 106.19668. Oops, ... Same deal for this future value. So this is the future value at n equal to 298. Now the only thing that changes here is our n. We've already got our new payment amount in there. And then we're solving for the future value again. And interest per year, present value, PMT. And remember, I'm only showing this work so that you can go back and check it. You do not need to show this work on the test. So N is 298, 3.9, 450,000, negative 2347.38. Solving for the future value, 12, 4, and end. And highlighting that the 298 is the only thing that's changed. So that's the only thing I need to update here before I can compute future value. And so here I get a future value of negative 4,669.986528. So after 298 payments, if I said, fine, I'm just going to pay it off, I would have to pay off 4,669.99. It's on sale. 4,669.99. We don't know what the values are leading up to it, but that's okay. Because now we can use this 4699.99 times recall 1. I get 15.13 rounding properly. And then take that away from the payment amount. Now all of a sudden I'm paying off quite a huge chunk of my principal. 23, 32, 25. And take that away from my balance owing. I should be one payment away, right? So it makes sense that it's 23, 37, 74. Here's where things get a little bit different. Because this is our last payment. We don't have any more chances to pay this off, right? And so this balance has to be 0. Which means that this amount has to be this amount, right, in order for this to be 0. So we have to force that to happen here. And so we write 23, 37, 74. But we also have to pay interest on that. So 23, 37, 74 times recall 1, so I2, is 757. I have to pay interest and I have to pay off that principal. So when I add them up, 757 plus 2337.74, I get a total of 2,345.31. which is different from the, not that different, but it is different than the other payments, right? And honestly, if I'm marking, yeah, I'm just looking, my eye just kind of goes to that last payment. If you got that right, I kind of just browse, looks good, great, moving on. All right, so I just go to that last payment, make sure that it's right. If it's not, then I look back. But so this is all you need to show for 6 marks, right? And then the last part, because I crossed it off, but I actually want to do it, is how much interest did we pay? What was the total amount of interest paid on the mortgage? That's going to be the total paid minus what we borrowed, right? So total interest is the total paid minus 450,000, right? Because that's how much we borrowed. The total paid is 299 payments of 2347.38 plus that last payment of 2345.31. Right? So we've got 2347.38 times 299. And then I'll put these in brackets because it's still the total paid, plus the last payment, 2345.31. All that minus 450,000. So I get 2347.38 times 299 plus 2,345.31. I paid $704,211.93, but I only borrowed 450,000, so minus 450,000. So the total interest paid is 254,211.93. Oh, you did it, guys. How's it feel? Well, first, any questions? That's business math. You did it. Now you just need to get it out on the final. Then it's over. It's not bad. Any last minute questions? I'll be around up until the final, so if you need help, then stop by or text me or email me or do whatever. Until then, enjoy your last week of classes. I'll see you later. I'll come back to that, but I'll stop this recording.